Okay, so your DCN exam is tomorrow, right? And you're probably feeling the pressure just a little bit. Take a deep breath. I see you and I get it.
But listen, do not panic. I've got your back. This right here is your complete, no-nonsense survival guide. We are going to walk through this together, and you're going to do great.
So, here's our game plan. First, we're going to blast through Unit 3, all about the physical stuff. Then, we'll nail down Unit 4, which is about making sure data gets where it's going. We'll zero in on the key comparison tables, the ones that always show up on the exam. Then, a quick-fire revision guide and some top questions to make sure you're ready. Let's do this.
All right, let's jump right into Unit 3. I want you to think of this as the actual physical infrastructure of the internet. It's the wires, the signals, it's the digital highways that all our data has to travel on.
First concept, multiplexing. Now, imagine if every single car needed its own private road to get to work. It would be an absolute nightmare and super wasteful, right? Of course. So instead, we build one giant highway and let everyone share it. That's all multiplexing is. It's just combining a bunch of different signals onto one shared channel. Why? To save money and be efficient.
Okay, so how do we share this big highway? Well, there are two main ways, and I promise you this comparison is a guaranteed exam question. First, you've got frequency division multiplexing, or FDM. The best way to think about this is like radio stations. You've got 98.3 FM, 101.1 FM. They're all using the air at the same time, but each one has its own unique frequency lane. Then you have time division multiplexing, TDM. This is more like a single-lane toll booth. Everybody uses the same road, but you share it by taking turns. One car goes, then the next car, then the next.
But, our digital highway isn't perfect. Things can go wrong with the signal. You need to remember these three main problems. First, attenuation. That's when a signal gets weaker the farther it travels. It's just like shouting across a big field. Your voice fades. Then there's noise. This is like static on the radio that messes up the song. It's just random, unwanted energy. And finally, distortion, where the signal literally changes its shape, kind of like looking at yourself in a wacky funhouse mirror. Okay, I need your full attention here. Put your phone down. If you only study one thing from Unit 3, make this. The comparison between switching techniques is, without a doubt, a guaranteed question. This is important for the exam.
And here are the two big ones you need to compare. On one hand, you have circuit switching. Think of an old-school telephone call. A dedicated private connection is made just for you, and it stays open for the whole call. On the other hand, you have packet switching. This is like the postal service. Your email gets chopped up into little data packets, like postcards, and each one can take a different route to get to its destination. When you write this in the exam, draw this table. Compare them on the path, how they use resources, and give a real-world example. It's a surefire way to get full marks.
Awesome. Let's switch gears to Unit 4. So, we've built our digital highways. Now, how do we make sure a piece of mail gets from one house to the very next house on the street reliably and without getting lost? That, my friend, is the job of the data link layer.
This layer has four main jobs, and they're super logical. Step 1, framing. It takes the raw data and puts it into a neat little package, like an envelope, called a frame. Step 2, addressing. It slaps the local address, the MAC address, which is like a house number, onto that envelope. Step 3, error control. It does a quick check to see if the envelope got torn or rained on. And Step 4, flow control. It basically makes sure the sender isn't jamming letters into the mailbox faster than the receiver can take them out.
So let's zoom in on that error control part. How in the world does a computer know if data got messed up along the way? Well, it uses error detection techniques. And honestly, the easiest way to think about it is like a spell checker, but for data.
Now for a classic exam example of error detection, the parity check. It sounds complicated, but it's really simple. The sender and receiver agree on a rule, like every message we send will have an even number of ones. If the data naturally has an odd number of ones, the sender just sticks an extra one on the end to make it even. Then the receiver gets it and counts the ones. If the count is odd, boom, it knows an error happened. Now, for the exam, you have to mention its biggest weakness. It's simple, but it can only reliably catch an error if just one single bit got flipped.
Okay, what about that other problem? What if the sender is like a super fast machine gun and the receiver is, well, not? If the sender just keeps firing off data, the receiver is going to get overwhelmed, its buffer will overflow, and data will just get lost. That's exactly why we need flow control.
And we've got two main strategies for this. The first is called stop and wait. It's exactly what it sounds like. The sender sends one packet, then stops,
and waits for an "Okay, I got it" message before it sends the next one. Super simple, right? But also super slow. The much smarter way is the sliding window protocol. With this, the sender can send a whole bunch of packets at once, a window full of them, without waiting for an OK for each individual one. It's way more efficient.
All right, last big idea for Unit 4. Think about Wi-Fi in a busy coffee shop. You have one shared connection, but tons of people trying to use it at the exact same time. What happens when everyone tries to talk at once? Total chaos, right? Data packets collide and get corrupted. So how do we manage this mess?
We use something called multiple access protocols. Just think of them in 3 main flavors. First, there's random access. This is like a polite dinner party. You listen to see if anyone else is talking. If it's quiet, you start to speak. Sometimes 2 people start at the same time. That's a collision, so you both apologize, wait a random amount of time, and try again. Then there's controlled access. This is like a formal debate with a moderator. You have to wait your turn for the moderator to call on you or give you the microphone. Very orderly. And finally, channelization. This is where you just split the whole resource up from the very beginning, like we saw with FDM and TDM. Everyone gets their own little slice.
Okay, we've made it to the home stretch. This is your rapid-fire last-minute revision. If you were totally crunched for time, just focus on these next couple of slides. This is the stuff you absolutely need to know.
For Unit 3, lock these in. Multiplexing. FDM is frequency lanes. TDM is taking turns in time slots. The 3 impairments. Attenuation is weakness. Noise is static. Distortion is a shape change. The big one. Switching. Circuit is a dedicated phone call. Packet is like efficient postal mail. And the modem? It just converts signals from digital to analog so they can travel on old phone lines.
And for Unit 4, here's your cheat sheet. The 4 jobs of the data link layer are framing, addressing, error control, and flow control. For error detection, your simplest example is the parity check. For flow control, you need to know stop and wait versus sliding window. And for multiple access, just remember the 3 categories: random, controlled, and channelization.
Now, I would bet money that you'll see some of these on your exam. Number 1, for sure, differentiate circuit and packet switching. Then FDM versus TDM, the functions of the DLL, explaining stop and wait, and describing those 3 types of multiple access protocols. You should be able to write a few solid sentences for each of these right now.
Let's do a quick pop quiz. Which layer handles node-to-node delivery? That's the data link layer. A modem converts what to what? Digital to analog signals and back again. What do we call a signal getting weaker over distance? Attenuation. And a dedicated path is the key feature of circuit switching. If you got those right, you are in very good shape. Okay, look, if you walk into that exam and your mind just goes totally blank, I want you to remember just these 3 things. Number 1, circuit switching is a phone call. Packet switching is the postal service. Number 2, the data link layer is all about local delivery. Its jobs are framing and error and flow control. And number 3, multiplexing just means sharing. FDM shares with frequency lanes, TDM shares by taking turns. This is your absolute safety net. Hey, you've got this. Seriously, we've covered all the high-yield stuff. Just walk into that exam hall, stay calm, and remember the simple analogies. The highways, the mail, the dinner party, they will help you structure your answers. You're going to do great. Good luck.
And after you've totally aced this exam, here's something to think about. We've figured out how a piece of data gets from your computer to the router just down the hall. But how does it get from your house across oceans to a server on the other side of the planet? Well, that's the magic of the next layer up. But for now, just focus on tomorrow. You are ready.